So hello everyone, welcome back to our Python programming fundamental series. I hope you are doing well. Before we start today's topic, let's quickly revise what we have learned in the previous lecture. Can anyone tell me what is a Boolean expression? Exactly, a Boolean expression is always gives either true or false. Now another question. Which statement is used when there is only one condition is to check? Correct. It's if statements. What if there are two possibilities? We use if else. Good. And when there are multiple conditions, we use if, elif, else. Excellent. We also learn logical operations like and, or, not, nested conditional statements, the modular operators, typecasting, random module, and match case statements. So, these concepts help Python make decisions. Now, today, we are going to learn something that every programmer uses almost every day. Let me ask you a simple question. Suppose I print only one time. That's easy, right? Print welcome. Done. Now, suppose I ask you to print it 5 times. What you will do? Some of you might write welcome, print welcome, print welcome, then print welcome. This works. But imagine I ask you to print 100 times. Will you write 100 print statements? Probably not. Now imagine 10,000 times. Sounds impossible, right? Here is the real question. Can we tell Python, repeat these statements 100 times instead of writing it 100 times? Yes. This is exactly why loops are created. So, why exactly do we need loops? Let's think beyond programming. Loops are everywhere in the real life. Every morning, your attendance is recorded for every student. Does the teacher manually write the attendance logic again and again? No. The same process is repeated for every student. Think about salary collection in a company. If there are 2,000 employees, do they write separate program for every employee? Of course not. The same calculation is repeated for everyone. Suppose a student wants to generate a report cards. Again, the same process is repeated for every student. Or think about an ATM, where hundreds of customers use it every day. ATM repeats the same steps like read the card, ask for the PIN, verify the PIN, perform the transactions, print the receipt. The process is repeated for every customer. These are all examples where the same task is performed again and again. The programming has exactly the same requirement. Instead of writing the same code repeatedly, we use loops. So what exactly a loop? A loop is a programming structure that allows us to execute a block of code multiple times until a condition is satisfied or until all items are being processed. In simple words, a loop repeats a task automatically. Think of a washing machine. Once you press start, does it ask you every second what to do next? It keeps repeating washing, rinsing, and spinning until the cycle is complete. Similarly, a loop keeps executing instructions until its work is finished. Now, let me show a simplest example. Let me open the ideally. Yep. Here, without a loop, print Python, print Python, print Python, print Python, print Python. The output will be Python, 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 Python. Now, don't worry of understanding the syntax yet, but I will show one another way. For I in range 5, print Python. it prints 5 times. We get exactly the same output. 2 lines of code instead of 5. And if I want to print it 100 times, do I write print 100 statements? No. I simply change that inside this range one. And if I run, it prints Python for 100 times. That's the power of loops. Now one important question. Does all are all loops the same? The answer is no. Python provides two main types of loops. They are for loop, the other one is while loop. Let's start with the most commonly used one, the for loop. Now that we understood why loops exist, let's learn our first loop in Python. This is called for loop. Before writing any code, let me ask you a question. Imagine your teacher gives you the attendance sheet containing 60 student names. Your job is to read every name one by one. How do we do it? You start from the first name, read it, move to the second, then the third, then the fourth. You continue until writing the last student. Notice something, you are repeating the same action on every student. You are writing different instructions for every single names. You are following one process. This is exactly how a for loop works. So what is a for loop? A for loop is used when we want to repeat a task for every item in a collection or for a fixed number of times. Think of these examples. Reading every student's name, checking every answer in an exam paper, sending the same email to 100 customers, displaying the product in an output online shopping app, printing every comment under a YouTube video. All these situations, we are doing the same operation again and again. So instead of writing the same code repeatedly, Python gives us the for loop. So our first for loop will be, first let's open the Python ideally. Do as I am doing here. For I in range 5, print hello Python. So if I save it and run, it prints Python 5 times. So before pressing enter, pause the video for 5 times. Try to predict the output. How many times will hello Python will be printed? Will it be 4, 5 or 6? Now let's execute it. The output is hello Python and it's printed for 5 times. But now a new question arises. Where did the 5 come from? And what exactly the mysterious I? Don't worry, we will understand both. So understanding I. Many beginners think I is some special Python keyword. This is not. It's just a variable name. You can write for number in range. For number in range 5 or for student in range 5 or maybe for Bharat in range 5. Python does not care. The variable name is your choice. Traditionally, programmers use I, which simply stands for index or iteration variable. So don't memorize I. Understand its purpose. So instead of printing hello Python, let's print I. Here, the iterator is Bharat. So if I save it and run, it prints. Many beginners think 1, 2, 3, 4, 5 will be the output. Let's see. And when we run it, the output is 0, 1, 2, 3, and 4. Sounds interesting, right? But why didn't Python start from 1? Why didn't it start from 0? This is one of the most important things you will learn in programming. Programming starts counting from zero. Most programming languages, including Python, use zero-based counting. This is a row of blockers. Instead of numbering them 0, 1, 2, 3, 4, I mean 1, 2, 3, 4, programs often number them 0, 1, 2, 3. So range 5 does not mean 1 to 5. It means start from 0, start and stop before 5. So the Python generates 0, 1, 2, 3, 4. This is exactly the 5 numbers. Let's understand it line by line. So in this, Python creates these numbers mentally 0, 1, 2, 3, 4. Now imagine Python saying, let's put the first value into I. So the I value will be 0. And now execute print I. So the output will be 0. Next, Python changes I equal to 1 and again execute print I. Now the output will be 1. Then I value will be 2, print. Then I value will be 3, print. Finally, I value will be 4, print. After that, there are no more numbers left. So the loops ends automatically. Notice something beautiful. We never increased I ourselves. Python handled everything automatically. This is one of the biggest advantage of a for loop. So let's try another example. For I in range 5, print I comma square equal to I multiplied by I. And if can anyone guess the output? Yeah, pause the video and guess it. Now let's run the output. So it prints 0 squared equal to 0, 1 squared equal to 1, 2 squared is equal to 4, 3 squared is equal to 9, and 4 squared is equal to 16. Observe how only one line of code calculates square of multiple numbers. This is exactly the real power of loops. Instead of solving one problem, we solve many problems similar. We can solve many similar problems automatically. So before moving ahead, let me show you three mistakes almost every beginners make. So mistake number one, which is missing the colon. So Python immediately gives a syntax error. So always remember the colon. Mistake two, wrong indentation. Again, Python complains the statement needs inside the loop must be indented. Mistake number three, thinking I starts from 1. This is probably the most common misconception. Always remember, range of 5 means it starts from 0 and ends by 4, not it starts from 1 and ends by 5. This is an invalid one, and this is a common mistake that the pro beginners do. So, now that we have understood what a for loop is, and how it works naturally and how Python changes the loop variable, we are now ready to explore one of the most powerful companions, that is range function, which gave us the precise control over how many times a loop runs and the sequence of values it generates. That's exactly where we will come to the next section. The PPT introduces range as a function that generates a sequence of integers and shows its different forms. Range stop, range start stop, range start stop step. We will be building our understanding in the same order as well. So far, we have written this program for I in range 5, print I. So most beginners memorize this, but we'll be slightly doing different. Today, I don't want you to memorize it. Instead, instead, I want you to understand what range actually does. because once you understand range function, writing loops becomes much easier. So what is range? Let's understand the word range. In English, the range means sequence or a group of values between two limits. So let me go. Okay. So for an example, if I say the age range of a computation is 18 to 25, that means all ranges, all ranges from 18 up to 25 are valid. Python uses the same idea. The range function generates sequence of numbers. It does not print them. It simply creates one after another. For the for loop, the they then picks each number and processes it. Think of it like imagine your teacher writes these numbers on board 0, 1, 2, 3, 4. The teacher is in range. Now imagine another student comes and reads one number at a time. The student is the for loop. So remember this range creates the numbers. For loop uses those numbers. Many beginners think both do the same job, but they don't. Each has a different responsibility. So let's start with the simplest form, range stop. So here, as we have already made this code, this we already know what kind of output it will be. It will be 0, then 1, then 2, then 3, then at last 4. Notice something, we wrote 5, but Python never printed 5. Why? Because the stop value is never included. This is one of the most important rules of range. Say it once more so you like the stop value is always excluded. If I write range 10, what Python generates, it generates 0, then 1, 2, 3, 4, 5, 6, 7, 8, then 9. That's it. So not 10 because the stop value is always excluded. So can we try it? Yeah. So the star it starts from 0 and it goes till 10, 9. Okay. So let's verify this one. If I have for I in range 3, print I. What will happen? It prints 0, 1, 2. Now let me change it to for I in range 8. What does it print? It prints 0 to 7. Notice the pattern. Python always starts from 0 when we provide only one value. Suppose I don't want numbers from 0. I want only numbers from 5 to 9. Here I will be having 5 to 10. Then save it and print. So can anyone predict the output? Yes, the output will be 5, 6, 7, 8, 9. Again, the stop value 10 is not printed. Suppose your classroom roll numbers start from 21 and end at 30. Instead of writing every numbers manually, you can write for I in range 21 to 31 print roll number comma ROLL comma I. And if I save it and run, it gives some much cleaner output. So the next one is start range. Range of start, stop, step. Now let's make even more interesting. Suppose I want only even numbers. Should I print 2, 4, 6, 8 manually? The answer is no. We use something called step. So this step tells Python after printing one number, how much should I move forward? Let's write it. So I'm starting from 0, moving till 10, then with the step of 2. And if I print I, it prints the even numbers. Let's check it. For first time, the output, the range gives numbers like 0, 2, 4, 6, 8. 10 won't be included as the last value is always excluded. Okay, so This this will be the probable output. So let's try. Yes, the probable output is 0, 2, 4, 6, 8. Perfect. Python starts from 0, then jumps by 2 every time. This is exactly the third parameter, the step size works. Now, let's print only odd numbers. I'll be starting from 1 and moving till 10 with the step value 2. And what does it do? It starts from 1, 3, then 5, then 7, then 9. So this is how Python works here. And if I save it and run, it prints 1, 3, 5, 7, 9. Notice how we changed only the starting value. The step value remains 2. Many students think bigger loops can move only forward. That's not exactly true. We can also move backwards by having start value as 10, end value as 0 with a step value minus 2. With this, we can print 10, 8, 6, 4, 2. So the negative step tells Python move backwards. This matches the final range example shown in the PPT. Let me show the PPT so that you can understand the final example too. Okay, so these are some examples where for n in range 5 to 10, print n, comma n equal to space. This prints 5, 6, 7, 8, 9. So, and this is step value like stop step, it means start, stop, step. And the third one is the same thing, but instead of having forward, we are having backward one. Okay, so there are three forms to remember. So let's summarize this. There are range stop. This starts from 0 and then range start stop. So starts wherever you want and then range stop step. Tells you control how much to jump each time. By default, step value in Python will be 1, but we can change whatever we want. The stop value is necessary everywhere, but the start value is default 0. Okay, so common beginner mistakes. So before moving ahead, let me show you these mistakes. Mistake number 1. Students expect range 5 to include 5. It doesn't. The stop value is always excluded. And mistake 2. Writing 10 comma 1 and expecting this thing won't work. Python gives nothing because it does not know how to move backward. So you must specify 10 comma 1 comma minus 1. And mistake number 3, forgetting what the third parameter means. It is step size, not the ending value. Now we have completely understood how range generates sequences. Now the next question is, what if we don't know how many times we need to repeat something? Suppose we want to keep asking the user for password until they enter the correct one, or can for loop help? Not really. That's where Python gives another powerful loop called while loop. The PPT now introduces the while loop. This explains that it runs as long as condition remains true, gives a counting example, and then discusses infinite final loop. We will expand those ideas into a beginner-friendly explanation. So far, we have learned the for loop. The for loop is amazing when you already know how many times something should repeat. For an example, print numbers from 1 to 10, print a multiplication table, print all student names. In all these examples, we already know how many iterations are needed. But let me ask you something. Suppose I ask you to create an ATM machine. The ATM keeps asking, enter your PIN. If the PIN is wrong, it asks again and again and again. Now tell me, can you predict how many attempts the customer will take? Maybe 1, maybe 3, maybe 10. Nobody knows. So, can we use for I in range 3? No, because we don't know beforehand how many times a loop should repeat. This is exactly why Python gives us another loop called while loop. So what is a while loop? A while loop keeps running as long as the condition is true. The moment the condition becomes false, the loop automatically stops. Notice the difference. A for loop usually says repeat this many times, while the while loop says repeat until the condition becomes false. This is the biggest difference between the two ones. So let's understand through daily life. Example 1, mobile charging. Imagine your phone battery is at 20. You connect the charger. Will you unplug it after exactly 37 minutes? Probably not. Instead, you keep charging. While the battery is less than 100, when it reaches 100, you unplug it. This is how a while loop works. So, example 2, washing machine. A washing machine keeps spinning while the timer is not over. Once the timer reaches 0, it stops automatically. And then YouTube login. Suppose YouTube asks you to log in. If you enter the wrong password, it asks again. And if you are still wrong, it asks again. The process continues while the password is correct. As soon as the correct password is entered, the loop ends. Example 4, playing a game. Think of a racing game. The game keeps running when you are alive. The moment your car crashes, the game over. The loop stops. Can you see a pattern? Every example and one thing is common. The repetition depends on a condition, not a fixed number. So let's write our the first example together. 1 minute. Yep. Here I'm having count equal to 1, while count is greater than or less than or equal to 3, print count. Then have count plus or equal to 1. Don't worry if it is looking confusing, we will understand each line. So let's imagine Python is executing the program. Initially count is 1. So the value of count is 1. Now the Python reaches while count less than or equal to 3. The Python asks only one question. Is 1 less than or equal to 3? The answer is yes. So, since the answer is true, the Python enters the loop. The loop body is this. So, it executes print count. So, the output will be 1. So, the output will be 1. Then, count plus or equal to 1 makes I 2. So then Python again goes back to the top and notice something important. A while loop always come back to check the condition again. It does not continue downward immediately. Again the Python asks is 2 greater than or equal to 3. The answer is true. Yes. Okay, so it prints 2 and now it increases the count value. Now again after this thing goes back again up and then it checks for the condition. Now count value is 3. Is 3 greater than or equal to 3? The answer is true. So what does it do? It prints 3 and the count value becomes 4. Now Python checks 4 is less than or equal to 3. It's false this time. So Python immediately exits the loop. The program is finished. Notice something, inside a for loop, Python automatically changes the value. But inside a while loop, we must change the value. Python will never do it automatically. This is one of the biggest difference between for and while. Let's experiment one thing. If we have count equal to 5, will it print anything? No, nothing happens because with the very first condition itself, 5 is greater than or equal to 3 is already false. Since the condition is false, Python never enters the loop. This is another important concept. A while loop may execute 0 times if the condition is false from the beginning. Let's create a countdown type. While count equal to 5 and then count greater than 0. Print count minus equal to 1. And what will be the output here? On the first run, Python prints 5 as the condition becomes true. Then count value becomes 4. Python prints 4. Then count value becomes 3. Then Python verifies the condition and it prints 3 and count value becomes 2. Python verifies the condition and it prints 2. Condition becomes 1 and then Python prints 1 and count becomes 0 and the program stops. So let's see it. 5, 4, 3, 2, 1, blast. Simple, but it teaches how while loops are commonly used. Common beginner mistakes. Forgetting to update a variable. I mean, here, instead of having this one, if we just leave it, what will happen? The condition is always true and the count never changes. The program keeps printing 5, 5, 5 forever. The computer never knows when to stop. Mistake number 2. Updating in the wrong direction. If the condition is greater than or equal to 0, but if I have count plus or equal to 1, will this condition ever become 5? Instead of decreasing, if it is increasing, the value becomes 5, 6, 7, 8, and it will be going beyond. And it will never come to the condition and then become false. So again, the loop never ends. Now let's understand the term you will hear very often, infinite loop. Infinite loop is simply a loop. Wait 1 minute, let me open the slide. Infinite loop is nothing but simply a loop that never stops because its condition is always remaining true. The PPT shows a classic example, print, while true, print it's Bharat. Since true never becomes false, the message keeps printing forever when you manually stop the program. Where are infinite loops are actually used? You may think, why would anyone intentionally create an infinite loop? Interestingly, professional programmers do this all the time. For example, a web server keeps waiting for new users. A game keeps running until the player quits. The operating system keeps running until you shut the computer. These programs are designed to keep working continuously. The difference is that they include a way to exit the program when needed. So this so in the next section, we'll be going through the break statement. So as we already seen, these infinite loops are made necessarily they they need it continuously working and they have a way to exit the loop when needed. So we'll be seeing some jump statements or skip statements which make the loop skip or end the loop without have complete process. So let's see in the next topic. So far, we have learned how to make loops repeat, but now let's imagine a different situation. Suppose your mother asks you to go to grocery shop and buy eggs. You enter the shop, start looking shelf by shelf, shelf 1, not the shelf 4, shelf 2, not the shelf 3, and finally you find the eggs. Now let me ask you, after finding them, will you continue searching every remaining shelf in the shop? Of course not, right? This that would be a complete waste of time. The moment you find what you are looking for, you immediately stop searching. This is exactly the purpose of break statement. So what exactly is break? The break statement immediately stops the current loop. The moment Python encounters break, it exits the loop completely and starts executing the code after the loop. Think of it like pressing the emergency stop button on a machine. No matter where the machine is in the cycle, everything stops immediately. This is exactly what break does inside a loop. So let's understand this through everyday situations. Imagine you are looking for your friend in a classroom. You check the first bench, not there. Second bench, not there. Third bench, there he is. Will you continue checking the remaining benches? No, right? You will stop immediately. That's his break. Finding your seat in a theater. You walk through row A, not your seat. Row B, not your seat. Row C, seat number 12. You found it. You don't continue searching the remaining rows. You stop. Again, that's break. Password validation. Suppose an application allows only 3 attempts. The user enters correct password on the second attempt. So the application continue asking for a password the third time. No, right? The loop should stop immediately. Again, break is working here. Our first example says for I in range, like let us try the first example. Give me a minute. Yep. So here for I in range 1 to 11, if I is equal to 6, print, break, print I. And if I save it and run, it prints 1, 2, 3, 4, 5. Notice something interesting. Where is 6? Many beginners expect 1, 2, 3, 4, 5, 6. But this is not what happened. Let's understand why. The Python starts the loop with I equal to 1. The program Python checks if I equal to 6 false. So Python prints 1. Next, I becomes 2. Again false, print 2. The same happens for 3, 4, 5. Now comes I equal to 6. The Python checks if I equal to 6. This time it is true. So the Python executes break. The moment break runs, the Python immediately leaves the loop. Notice carefully, it does not print 6. Why? Because break statement happened before the print statement itself. Therefore, the order of the statement matters. This is one of the most common beginner's mistake. Okay, let's experiment with some simple change. Instead of having print I here, I'll be having print I here. And if I save it and run, it prints 1, 2, 3, 4, 5, 6. Sounds interesting, right? So why did 6 appear now? Because this time Python printed first, then checked the condition, and only after printing did it execute break. This teaches us the important lesson. Python is not just about the statements you write, this is also about the order in which they are executed. Now let's understand with the example from the slides. Here in this example, A is 1, 3, 5, 7, 9, 11 and the value is 7. For I in A, if I equal to value, print found at the value and else not found. This example searches for a value inside list. The loop stops immediately when the value is found inside of checking the remaining element. Let's understand it slowly. Our list is 1, 3, 5, 7, 9, 11. We want to find 7. The Python starts checking. Is 1 equal to 7? No. It moves on. Is 3 equal to 7? No. It moves on. Does 5 equal to 7? No. Move on. So is 7 equal to 7? Yes. Immediately, Python prints found at 7 and exits the loop. Notice something, Python never checks the rest of other elements like 9 or 11 because once the work is finished, There is no reason to continue. This is the big advantages of break. This saves both time and computer resources. What if we don't use break? The answer is still correct. Yes, but Python still checks 9 and 11. Even though it already found 7, for a list of 6 elements does not matter much. But imagine a database containing 10 million records. Finding the answer early and stopping immediately can make your program much more efficient. There are some common beginner mistakes which most of them do. So the mistake number one, thinking break stops only in the if statement. No, it stops entire loop. Mistake number two, thinking break ends the whole program. No, it only exits the current loop. Any code that after the loop will execute. For an example, for I in range 5, let me do it. For I in range 5, colon is important. If I equal to 2, then then break. After that, print program continues. Print here. Print its bar. Now, if I save it and run, it prints program continues here and its bar. But as the break statement did not end the program, the break statement only ends the loop, not the program. So pause the video and try yourself without running the code, predict the output. Let me run the code. Let me type the code so that you can predict it. For I in range 1, comma 8, if I equal to 4, break. Then print I multiplied by 10. After that, print loop finished. So take a minute, write your prediction on a paper, then execute it. If your prediction matches the output, you are starting to think like a programmer. So let's try it ourselves. So the first iteration I becomes 1 and it checks I equal to 4. The answer is false. So it prints 10. Then Python goes I equal to 2 and it checks whether the condition becomes true, false. So Python prints 20, then 30. But when I becomes 4, the condition becomes true and then it ends the loop. So the output will be 10, 20, 30 and then loop finished. Okay, so let's try it. 10, 20, 30 and then loop finished. So let's summarize what you have learned. A break statement immediately exits the current loop. It is commonly used when we are already found what we are looking for. It is commonly used when we are already found what we are looking for. This helps understand, this helps avoid unnecessary iterations. This helps and making program more efficient. The position of break inside loop matters because the Python executes statements from top to bottom. Now here there is one interesting question. What if I don't want to stop the entire loop? And what if I simply want to skip only one particular iteration and continue with the remaining ones? For that, the Python provides a new very useful statement called continue. So far, we have learned about break. Let's quickly remember what it does. Imagine you are watching a movie. or halfway through, the electricity goes off. The movie stops completely. This is exactly what break does. It simply stops the loop. Now, here's a different situation. Suppose you are reading a book. One page is damaged. Can you still continue reading the rest of the book? Of course. You simply skip that one page and continue reading the next one. This is exactly what continue does. So it does not stop the loop. It simply skips the current iteration and move to the next one. This is biggest difference between break and continue. So what exactly is continue? The continue statement tells don't execute the remaining code of this iteration. Instead, jump directly to the next iteration. Notice carefully, it skips only one iteration. The loop keeps running. Real life examples like let's understand this some everyday situations. Example 1 attendance. Imagine your teacher is calling attendance. Roll number 1 present. Roll number 2 present. Then roll number 3 absent. Does the as teacher stops taking attendance? No. The teacher skips roll number 3 and continues roll number 4. Let's continue. Example 2. YouTube comments. Suppose you are reading comments on a video. Most comments are genuine, but one comment contains spam. Do you stop reading all comments? No, right? You ignore the spam comment and continue reading the rest. Again, that's continue. Example 3. Cricket team selection. A coach is checking players. One player is injured. Does the coach stop the selecting process? No. He skips the player and continues checking everyone else. Again, continue. And let's write an example from the PPT. That is, for I in range 1, 11, if I becomes 6, continue. Then print I. So this example skips printing number 6 while continuing the remaining numbers. Before running, pause the video and predict the output. Will the loop stop or will just only one number disappear? Now run it. Output is 1, 2, 3, 4, 5, then 7, after that 8, 9, 10. Notice something, the loop did not stop. Only number 6 is missing. Everything else is printed. So let's understand it step by step. The initially I value is 1. The Python checks if I equal to 6, false, print 1. Then next 2, I equal to 2, false, print 2. Same happens for 3, 4, 5. Now the I value is 6. The Python checks if I equal to 6, true. So instead of executing print I, the Python immediately jumps back to the beginning of loop. So 6 is skipped. Now I equal to 7. The condition becomes false again. Python prints 7, then 8, then 9, then 10. Then loop completed. So students confuse these two all the time. Let's compare them. So if I'm having break, what does it do? It ends the loop completely. But if I have continue in place of break, let me see. Let me give this thing. Instead of continue, if I keep break, what will happen? It prints 1, 2, 3, 4, 5. It ends the loop and does not print the rest spinning things. But if I have continue, see the difference. Okay, break leaves the room completely, continues, keeps one room and continues walking. That's exactly the way to remember them. So let's make one small change. For I in range 1, 11, if I modulus 2 equal to 0, continue, then print I. Pause the video. Can you guess what will happen? Yes, exactly. It will print the odd numbers. Let's run it and see. Why? Whenever Python finds an even number, it keeps printing it. This is one of the most common real world use of continue. Let's try one another practical example. Here, I'm having a list of exam marks with 95, 82, -1, 76, 91. And then here minus 1 means student was absent. Do you want to calculate anything for absent students? No, right? So here for marks in for mark in marks, if mark equal to -1, continue, print processing mark. So the output will be processing 95, processing 82, processing 76, processing 91. Notice the absent student was ignored. The program continues processing everyone else. This is exactly why continue is useful in real world situations. Where is continue used? The PPT clearly lists some situations. Let's understand them with examples. Skipping specific data. Suppose a list contains empty values. Instead of stopping, we can ignore them. Filtering data. Suppose we want students who scored above 80. Anyone below 80 cannot simply be skipped. Ignoring unnecessary work. Imagine shopping a website. Some products are out of stock. Instead of processing those products, the program skips them and continues with available products. This saves processing time. So there are some beginner mistakes which mostly done when they are learning continue. So the mistake number one, thinking continue will end the loop. No, we already saw the difference between break and continue, and the continue only skips only one iteration, not the entire loop. Mistake number two, thinking everything after continue still executes. So in the previous examples, what beginner thought that we can print 6, but with the continue, the upcoming statements were skipped. So it never will. Why? Because once Python executes continue, it immediately jumps to the next iteration. Everything below continue inside that iteration is ignored. So now pause the video and try running this one. For I in range 1,8, if I equal to 4, continue, then print I multiplied by 5. Write your answer first, then execute it. If your prediction is correct, you are beginning to understand the loop control statements very well. Let me run it. Wait a minute. 5, 10, 15, 25, 30, and 35. So let's summarize what you have learned. Continuous gives only current iteration. The loop does not stop. It is useful when we want to ignore specific values without ending the loop. The break ends the loop completely. Continuous skips one iteration and keeps the remaining loop running. Now imagine you are writing a program, but you haven't decided what code you should go with inside a loop or an if statement yet. Python normally gives an error if the block is empty. So how do programmers leave an empty block temporarily? This is where pause statement comes in. We have learned two loop control statements like break, continue. But let's learn something completely different. Imagine you are building a new house. The architect has drawn the complete blueprint. The rooms are marked kitchen, bathroom, and bedroom. Everything is planned, but the construction hasn't planned yet. The rooms exist, but they are still empty. That's exactly what the print statement is. It tells Python, I know something should be there here, but for now leave it empty. What is pass? Pass is a statement is called a null statement. It simply means it does absolutely nothing. No output, no calculation, no error. The Python simply reads it and moves on. So why does it even exist? Because Python requires every block to contain at least one statement. So if you leave a block empty, the Python gives an error. Suppose let's have a code. Let me have it. So, yeah, here I'm having. Suppose if true, and then there is nothing below. The Python immediately gives expected intent block after its if statement on line 1. So why? Because Python expects some code inside the block. Now let's fix it. I'll be having pause and then print program finished. And if I run it, the program is executed successfully and the output shown as program finished. The pause simply acted as a placeholder. So imagine you are writing a notebook. You create headings like chapter 1, chapter 2, chapter 3. But today you only complete chapter 1. The remaining chapters are empty. Does that make your notebook invalid? No. You plan to fill them later. The pause is exactly the same empty chapter. There are some empty functions where we can use pause. For an example, def welcome. The functions will be discussed in the next lecture. So if I save it and run, there's nothing. Just later you can replace pause with actual code. So where and all pause is used. So pause are actually used where while planning programs during software development, when writing functions first and then implementing them later during debugging. Professional programmers use pause quite often while building large applications. There are some common mistakes. Many beginners think pause means skip. It doesn't. It tells that's continue. Skip means continue. Pause literally means do nothing. Quick recap. Pause is just a placeholder. It performs no action. It prevents syntax errors. It is useful when developing programs. Since we have studied in detail in lecture 2, let it be this will be a quick revision of match case. We already saw about match case, so let's move to the next one called for else. I mean for else and for while else. Many students don't even know this feature exists. Python allows an else with loops, but this else does not behave like an if else. Let's understand. The PPT demonstrates that the if-else block executes only if the for loop completes normally without encountering a break. So let's have an example. Here for I in range 5 and then print I. Give me a minute. Here. Else print loop finished loop finished successfully. And if I run it, it prints 0, 1, 2, 3, 4, and then loop finished successfully because the loop completed naturally. Now let's introduce break here. If I equal to 2, break, then print I, then print finish. So what does it do? It prints 0, 1. Notice the else is never executed. That's the rule. If a loop ends because of break, then else block is skipped. So real life example. Imagine checking under attendance. If you have successfully verified every student record, the principal says attendance completed successfully. But if there is a fire alarm rings in the hallway and the attendance is interrupted, no completion message. Exactly now, the if or else work. If while else. So this PPT shows while else follows the same rule for the else. Let me show it. Yep. Was similarly when there is terminated by break. So this brings loop completed. But if there is a break, it never else never executed. So the rule is identically for and else. So there is one memory trick. So instead of else, consider as a completion certificate. If the loop finishes normally, you receive the certificate. If it stops because of break, no certificate. So here, in this PPT includes several small loop-based practice programs. Let's walk through them and encourage viewers to pause and try them before seeing the solution. Whenever you are learning loops, don't just watch, pause the video, try the program yourself, then compare your answer. Some excellent beginner practice programs are printing numbers from 1 to 100, printing even numbers, printing odd numbers, printing multiplication tables, calculate sum of numbers, find factorial, reverse counting, and then print stat patterns. These programs strengthen your understanding far more than simple reading theory. So here I'll be trying only two examples for your reference. I'll be doing program to make sum of n numbers. So for that, I'm having x as 0 means sum as 0. Then for I in range 10. So it goes till 9. So sum plus or equal to I. After that, outside the loop, I'm printing print sum. And if I save and run, it prints 45. So the first program is successfully done. The second program is printing factorial. Factorial means if I have factorial 5, it is 5 multiplied by 4, multiplied by 3, then multiplied by 2 and multiplied by 1. So notice something, it's just product of 1 to 5. And if it is 10, it is product of 1 to 10. So here I'll be having prod equal to 1, then for I in range, and before that I'll be having x input, enter a number. Here the loop goes till x plus 1 and starts from 1. So prod equal to and multiplied equal to I. Then outside I'll be printing prod. If I save it and run, prints enter a number, I'll be giving 10 and gives the number output. And if I have a simple input like 6, it prints 720. So this is the exactly correct output. So I hope we have understood how to practice programs. So these programs strengthen your understanding far more than simple reading theory. So There, congrats, you've learned some of most important concepts in Python programming. We have covered why loops are needed, for loops, range, while loop, infinite loops, break, continue, pause, and then for else, while else, and some practice programs also. So at this point, you can solve wide range of varieties of beginner Python programs involving repetition and decision making. The next lecture, we will build on this fundamentals with even more practical programming concepts. Thank you so much for watching, and if you found this lecture helpful, keep practicing the examples yourself because programming is a skill you develop by writing code, not just by watching videos. So far, we have learned how to control loop using break, continue, and pause. We will also understand a special behavior of for else and while else. These concepts form the foundation of many Python programming problems. In our next lecture, in particular, we will take these loop concepts one step further. We'll learn about nested loops detail and use them to solve interesting pattern program printing problems like square, triangles, pyramids, and many more. Pattern printing is one of the best ways to strengthen your understanding of loops. So we will dedicate this an entire lecture to it. I mean the partial lecture. After that, we will be having introductory to functions also. Until then, I encourage you to practice all the loop-based problems we have discussed today, and more you code, the more confident you will become. Thank you for watching this lecture. If you found it helpful, keep practicing. I will be seeing you in the next lecture. So happy coding.